Perfect. So I'll pass you over to Lindsey, who's from University of Strathclyde.
Thank you. So today I'm going to be talking about some online skills quizzes that we introduced into a first year maths core class, and I'm not looking at what the quizzes are and how we set them up, but more looking at how the students engaged with the quizzes. And I'm going to draw an analogy with Wordle. So I'm hoping that most of you are aware of Wordle, if not already addicted to still playing it every morning before your morning coffee. For those of you that don't know what Wordle is, it's a word game online. You have to guess the correct 5-letter word. It's got really good feedback in it. If your letter's correct and in the right place, the box turns green. If you've got a correct letter but it's in the wrong position, it turns yellow. And if it's an incorrect letter, it turns grey. It's really nice feedback. This was for our core introduction to calculus class at Strathclyde. It's a class that all our first year students take. We've got about 150 students in it each year. And every cohort, we want them to take a skills test on basic mathematical skills. Those kind of things like being able to factorize quadratics, deal with logarithms, index laws, the things that ideally we want them just to be able to do and not have to think about. So skills quizzes used to be paper-based, and then pre-COVID, in fact, we moved on to an online system, and we created these stack skills tests. So I believe George later will be informing us all more about stack. For those that aren't aware of what stack is, basically it's an online system that allows you to do randomized questions, but allows students to type in mathematical answers, expressions as their answers. And they're marked right or wrong, and you can give them feedback in the form of correct work solutions for each question. So for our actual skills test, we had 16 questions. We'd set a pass mark of 12 out of 16, so 75%. We want the students to be able to do this, which is why we've got such a high pass mark. They have unlimited attempts at a practice quiz, but they can only attempt one credit-bearing quiz every week. That once they start it, they've then got an hour to complete it. They can complete one a week for the full 11 teaching weeks of the semester, but only the first 5 passes count. Okay, so each pass earns you 2% towards your final mark, up to a total of 10%. So what we expected is that students would attempt a quiz every week until they'd earned their 5 passes, and then they'd stop. And also that they would maybe use the practice quiz to actually practice and use the feedback to get better. What actually happened, I'm going to focus more on how they attempted the quizzes, is that we got this lovely different pattern of engagement. So I'm going to go through some different kind of people, cohorts in this. So these guys here were our expected behaviour. They earned their 5 passes and then they stopped. And that was about a quarter of the class. We've got these poor ones down here. They tried a few times, didn't get on with it. It wasn't working for them. Nah, it's not worth it. These guys, they love a quiz. They just, especially the ones right up here, 11 passes, 11 weeks. It was the best mathematical hour of their week. And that's just, yeah, they loved it. And then these ones, they just kept trying, but some of them, they just didn't quite get there. They were maybe sitting around about 60, 70% in the quizzes that they didn't pass. There was maybe one question that they weren't getting every week, but they weren't getting it every week over 11 weeks. So that's my kind of 4 patterns that we saw, my 4 kind of different cohorts that accounts for most of the class. So I started thinking about how does this kind of go with how we engage with games. So if you think about yourself, how do you engage with different games online? So there's some games that we play once or twice. We don't really like it. You delete the app, you move on. Sometimes you're playing games that you've got levels within larger games. You know, it's all a kind of, you complete the task that then unlocks the next task and you just keep going through. Some things, like Wordle, for me particularly, you love having that unbroken streak. That morning or that night when you realise that you've missed that day's Wordle and that's your streak broken, or it's even just the satisfaction of winning it every time. It's a small task, but just that satisfaction. Or you see the game as being substantially random, like Wordle, but you keep playing because you don't know when you start if you're going to get it or not. And in fact, in the literature, there's been shown that there's a higher kind of dopamine reward with these kind of games, that when you get it, there's a hit that you get from it. So why do we have these different patterns of engagement? Well, I think some of it is because most students attempt these quizzes on a mobile device, on their phone or on their tablet. They're not sitting at a laptop or at a computer. And these are also the same devices that they're playing these games. That's, you know, they're doing their stack quiz and then they're going to play Candy Crush. Generally, the students in the two middle categories, so the ones that had their 5 passes and then stopped, or the ones that loved the quiz, kind of unsurprisingly generally had higher attainment. So how do we reach these other students, the ones that try a few times and then stop? They just don't get it. It just doesn't work for them. But even more, how do we get these ones that plateau just below the pass mark? They're so close, they're so nearly there, but there's something that we're not doing that's just not helping them get over that threshold. And I think part of that with online quizzes is that we need to understand how they engage with games. And I think it's important that instead of focusing on do quizzes work for students, we need to focus on for which students do quizzes work and why do they work for those students, and how do we get the ones that it's not working for, how can we engage them and bring them along with the rest of the cohort. So that hopefully was 5-ish minutes. Thank you, everyone.
Very much. Does anyone have any questions for Lindsey? Got one from Jeremy.
I just show my question. I really like your little kind of 2D grid. How do you show the sort of relative frequency of the students in each category? Was each dot one student, or could some multiple students be perched on one of the
multiple students could have been perched.
So where was the most common place?
Oh, I can't remember off the top of my head, sorry.
Okay. Thanks.
Any more questions for Lindsey? No, sorry for those online, our microphone's not working, we will try and, oh, there we go. Now working. But thank you very much again to Lindsey.
Thank you.
So our next speaker is David Rees-Jones from University of St Andrews. Adobe. Yeah. I'll just pass over to David. Thank you.
Hello, everyone. Thanks very much. So I'm David Rees-Jones, and I'm a lecturer in applied maths. And I wanted to talk about a type of assessment that introduced during the pandemic time, but which I guess I think I'll continue with into the next academic year. So the context is teaching a 3rd year, typically honours module with, I don't know, 50 to 100 students. And traditionally, these modules would be assessed 80–90% by a final exam, and then the rest would be some kind of problem sets that students would do during the course of the module. And so I set as one task during the term, the students had to make a pre-recorded presentation. I guess that was something that we'd all been doing a lot, so the students had to have a taste of what it was like to make one of these things. Because obviously this could encompass a wide range of things, I'll just say a little bit more about what the task practically involved. So they were given a set of problems to choose from, I guess, on the kind of more difficult end of tutorial sheet problems, so that they were a bit more interesting for the students to think about. And they had to make a PowerPoint file they had to record audio of themselves explaining how to do the problem, and they then embedded that in the file and uploaded it. I told them how long it had to be in order to keep the marking manageable and so on. And the marking was out of 12. So the split was 5 was for doing the problem correctly, so the kinds of skills that would have been assessed on a normal tutorial sheet. 5 were for presentation skills, and then there were 2 marks for participating in a peer review activity. And this was a little bit like the second type of peer review activity that Jeremy was mentioning earlier, in that the marks were just for participation, and the students gave feedback, written feedback according to a rubric. So I kind of gave them some things to think about, and they actually provided extremely good, helpful feedback. So coupled with my feedback, I think they actually got very high quality feedback on both presentational and kind of understanding aspects. I showed some examples. These are generally good students, better than average students' work on this task, just to give you an idea of the kinds of things they did. So one of our problems was about calculating Fourier transforms, and I like this one because it had it combined a nice sketch. It used kind of highlighting to kind of guide you through. All of these ones could be improved, of course, but for the students, they'd probably never done something like this before. So this was their first attempt, as it were, of doing something like this. Okay, another problem was about calculating the potential associated with a set of charges. This one had a diagram and a color scheme which kind of matched with the equations they'd written down. And the last one, this was a bit harder to make a good presentation about. This was about calculating series solutions to ordinary differential equations. And this student had the strategy of kind of repeating some bits of the questions to try and kind of organize their answers. Okay, so I just showed these as a bit of a flavor of what was involved. So one of the things that I was trying to do with this was, sometimes we find that students just go through these kind of applied maths problems, working through the algebra, getting an answer, but often both in their written answers and when you talk to them, we wanted to try and develop that skill of explaining what they were doing, why they were doing it. And this was a kind of way of getting them to have to try and explain their answer rather than just list a whole set of algebraic steps. Some of them did fall into that trap of kind of just working through algebra, but I was trying to kind of move them away from that. For us, it was a bit more variety in assessment. In our school, the students typically only have to do presentations in their final project and maybe a few other modules towards the end of their degree. In other schools, before the pandemic, it would have been quite common for people to do presentations, but they would usually have been done in class and then to the whole class or some subset of the class, which some students find relatively stressful, and it's also quite time-consuming with a large group of students. So this meant that when you were doing the peer review, you were just reviewing 2 or 3 other students rather than sitting in a whole hour class. And for me, I was just marking them one after the other at a time. And the students could pre-record it, and so they could take their time to prepare, and so there was less stress of doing it right on the one attempt of doing it. So I think most students who did it liked it. They found that it took longer than the kind of equivalent credit weighting if I'd set it as tutorial sheets, but they thought they gained some more skills from it. I found it a bit of a challenge, at least the first time I did it, to mark consistently, especially with these different types of problems and very variable. I also found it hard to get a good range of marks. Almost all the marks were clustered towards the high end. I could have, of course, shifted that down a bit, but that was how it worked out. I chose to force people to use particular software to do this. And I provided a demonstration of like a presentation that I'd made doing some problem and a video of me making that presentation so that they could see how to do it. That was to preempt lots of people saying, how do I do it Beamer? How do I do it in Keynote? How do I do? So I just made everyone use PowerPoint, which was the software that the university provided. One downside of being pre-recorded and using audio only, although it's more kind of more accessible, I didn't have to have students recording a video of themselves and the file sizes are smaller and so on. The downside is it's a bit less dynamic than if they were standing in front of a class or if you were recording a video. Great, that's all I want to say.
Okay, David, any questions for David?
Thanks. I'm just interested in how you embedded some formative step into this, because it seems like quite a big workload to do that.
Do you mean like
feedback before final submission?
No, so I guess no, there was no feedback, but the whole task was only worth 10% of this year of the overall module. So they would have had feedback on kind of doing problem sheet style questions earlier in the module. So that kind of thing they would have had feedback on. The presentational aspect, I guess they've seen me making a demonstration, so they've seen someone else do it. Yeah, students ask for more demonstrations of good answers from previous years, but I wanted people to have a bit of an opportunity to be a bit more creative, and I didn't want everything to end up the same way. So I provided a kind of moderate quality example that I'd made.
Thanks, very interesting. Did you notice any discernible difference in the quality of the audio recordings? I know we often get told that you need very high audio quality for presentations, to be acceptable to students. I don't know whether the students all had well-level equipment or it didn't really make a difference.
No, they were all good. I think there would have been more variable if I'd asked for videos. No, I mean, you can just record it on your phone or with you don't necessarily need a laptop or anything like that to do. So, yeah, I found, everyone I could hear fine. Yeah. Some the greater variability was like the quality of people's typesetting of equations and things like that.
Thank you very much. I think we'll move on for the interest of time. So thanks again, David. Our next speaker is James Grant. That's you here, isn't it?
Yeah.
Okay, so now we have James Grant from Lancaster.
Perfect, thank you. So thank you for giving me the opportunity to speak. It's nice to be here. I did my master's in Glasgow about 9 years ago now, so it's nice to come back in an academic context. I'm going to speak about something today that I don't necessarily believe is yet an example of best practice, but something that I want to reflect on a little bit and to kind of throw around some of the things that I think are still issues in it. So this is in the context of teaching quite a large master's level module at Lancaster that was core for both our MSc statistics students, who are very much coming from a maths background, and MSc data science students who are much more homogeneous, some not having an undergraduate in the mathematical sciences. And this was co-taught by myself, who's been lecturing for a year or two now, and a more senior colleague. And it's a very broad and very introductory module. It covers, I think a piece of student feedback was we've peripherally covered almost every method that exists in kind of machine learning. That's a bit of an exaggeration, but we do within 5 weeks go through a lot of kind of different techniques at a very shallow level to prepare them for stuff that comes afterwards. So this then meant that producing an assessment that was individual, but kind of covered enough of the different learning outcomes of this very broad module was something that I found a little bit challenging. So we wanted to have a programming assessment that would assess their competencies in like run principal components analysis or a particular clustering algorithm, and not write a full report about it, not analyze all of these things, because we wanted to assess more different techniques, but verify that they could do them accurately. So what we landed on was this approach where they were each given a common set of questions, different data sets. They had 4 different data sets across the cohort, but they didn't know which one they were unless they asked their friend, what do your numbers look like? Mine look like this. We might have the same one. We gave them this kind of 24-hour window to complete this assessment, which looked like 3 or 4 different tasks, each requiring maybe sort of 5 to 6 lines of code and a numerical and a couple of sentences written answer, put into an R Markdown template, which was a piece of not software, but a format they were used to seeing their lab solutions in throughout the course. Why did we end up on this? These first 2 points of kind of having a common set of questions, not randomizing from a bank or not having more data sets, everybody having their own, they came from kind of setting time constraints, since the algorithms that were being used were a little bit more complex than just a hypothesis test or a simple regression. I wanted to be able to check that no one had a weird edge case where they couldn't answer the question because their data only had 3 clusters in it or something. And this kind of anonymity was what I could do within that to guard against collusion. The 24-hour exam window, that was kind of inherited from the COVID era and was an alternative to invigilating a programming assessment, which we didn't really have the facilities or the room capacities to do. And I hoped that by asking them to produce their code as well as their numerical answers, it would help me a little bit to detect collusion, but also help me attribute marks where somebody didn't get the correct answer in the end. In the end, this assessment worked well in that it threw up a lot less issues than I thought it might. I thought I was going to have 24 hours of emails if I can't download this data set, I can't get this to work, why, I don't understand the question. It went reasonably smoothly, and it was actually quite easy to mark. I was worried about that as well, that I'd spend a lot of time clicking between markdown documents, but probably got it down to 5 to 10 minutes per student, which felt reasonable. So I would seek to use it again, but I think I would definitely try and modify this before using it again. And one of the big points, which I hate that is a driver of the way that I'm going to design assessments, but really was that collusion was near impossible to detect. And in particular, the efforts at collusion that weren't just panicked, stricken, oh, I'm going to copy exactly what my friend's done. If they made the slightest effort to change their variable names or put in an extra comment or line of codes, there's nothing that I or Turnitin could do over 110 students. More so, I think it's still not right in that they did very, very well. It was all right because they didn't do so well in the written exam, so it all kind of balanced out, but it was hard to pitch for the first time with this assessment from a large cohort and a large varied cohort where a good level for an individual 24-hour assignment is. So I want to kind of think about these things a little bit, and I wanted to speak about it as a bit of a conversation starter if I run into some of you later on as well. So thank you.
Thank you, James. Any questions for James? Any on Slido? No. I think we feel the same way about difficulties in detecting collusion with, especially with programming, because if they change one variable name, you take it to Senate and Senate say, well, it's different. So yeah, so I guess Craig teaches our programming course.
Absolutely feel this pain quite a lot. So yeah, I understand that it's something that's very difficult, especially in the programming course, unless, like you said, it is like for like identical variable names, and the variable names are so the variable names are so absolutely specific, then it's quite easy to spot. But in general with coding, because you're using similar functions, especially if you're asking them to use R packages, if you're using R, for example, or Python, there's only one way to really use the package. It's only really when you get into kind of more functional programming that it can be a little bit easier to spot. And it's probably more in terms of the actual write-up. So if there's a report writing, which you said with Markdown, is likely something is a bit easier to spot with things like Turnitin. But it's an interesting topic, and it's one that probably needs explored. And Jeremy is probably a good man to talk about this.
Yeah, I was just going to say what we do in computing science, following on from your comments. So, Craig, I think we look at the syntax trees. So rather than looking at the actual textual variable name, look at the syntax tree of the program. And if that's similar, then you know that things are pretty suspicious. But with very small programs, like you say, you'd expect similar kind of sequences of function calls themselves, so maybe that doesn't work in your project.
Yeah. I think just to say on that, I think one of the interesting things as well is that since it's an open book exam anyway, in some ways I would rather them, I think it's more productive if they discuss it with their friend and the two of them work together and get a good answer than the opposite of Stack Exchange or something, which again is still authentic. So it's a tricky one.
I know. I think it's using Stack Overflow is something you do in your day-to-day job, so it's an authentic thing to teach them.
Exactly.
So thank you very much, James. Our next speaker is Alena. And you have two. Well, open them both and then you can just switch between them. You part one to begin with. Okay, so our next speaker is Alena from University of Liverpool.
Thank you. So I would like to talk to you how I use online electronic assessment in a large undergraduate statistics module. So this is the second year statistics module with more than 500 students. And this module covers standard statistical tests like t-test, ANOVA, and simple linear regression. For online assessment, I use Mobius Courseware platform, which is platform for electronic assessment. And I decided to use this platform because University of Liverpool has license for this, and we have expertise in our department. So this is the assessment strategy in the module. So there are two online Mobius class tests. So these class tests assess the use of statistical software R, and they assess threshold concepts using scaffolding, which guides students then towards higher order material, which is then assessed in final in-person written exam. So online class tests are marked automatically, satisfying all usual aims for assessment feedback. So since I introduced the online assessment in my module, there have been positive impact in this module as predicted by the literature. And this is a summary of these benefits. And these are the links to the literature. But now what I really would like to show you is some sample questions in Mobius. To make it a bit bigger. Yeah. So this is one of the examples of the questions I'm using. So in this question, students are asked to do calculations by hand using calculators and tables. So the highlight list parameters are randomly generated. So every student has different parameters. So you can see that we have hypothesized mean, randomized sample size, sample mean, and population standard deviation. So now here is the example of scaffolding I am using. So this scaffolding consists of breaking down the steps of hypothesis testing into small parts. So first, students are asked to state null and alternative hypothesis. Then they need to enter what's the test statistic of the test, choose what's the distribution from which the critical values are obtained. And then based on these results, they need to figure out at which level we can reject or cannot reject the null hypothesis. And then based on that, they need to make a practical interpretation by filling in some gaps into this sentence. So also then there is a question about the confidence interval for the population mean. So I believe that thanks to this scaffolding approach, students are able to learn and understand better all steps in hypothesis testing, which also then contributes also to higher or better quality results in their final written exams. So so this is example of the feedback which students then see when they get the results of their test. So on the left-hand side, this is the student response and on the right-hand side, it's the correct response. So students can see nicely where they get wrong and compare their actual responses with the current responses. And then in the end of every question, there is the feedback of the student for students, which contains all the formulas which were used for computations. And also the feedback is written in a formal way using full sentences and explanations, which is expected of students to write in this form in their final written assessment. So it's also a way to prepare them for the writing up the results in their final assessment. So another type of question is the question where they have to use R. So here we have data which are randomly generated. So again, each student has different sets of data, and they're asked to copy this data into Excel and then load this Excel into R. So the scaffolding approach is done similarly as in the previous question, only this time students have to use R to answer the questions because they are asked about the p-values. So they need to enter what the p-value for this test is, which they can only get from R. And again, based on that, students have to answer follow-up questions about interpretation and rejections level. We also have questions about assumptions of the test. They have to also perform normality tests, and again, they need to enter p-values. We have also a question about f-tests to compare population variances when it's again scaffolding, but they have to again use R to enter p-value here and answer subsequent questions. So another type of question I use is type choose all correct statements. And in this type, I can assess some of the theory as well. So that's it from me. Thank you for your attention.
Very much. Any questions for Alena? Have a quick check on Slido. If not, right. Thank you very much again. We'll move on to our final speaker. So our final speaker, David, couldn't make it to Glasgow. He's joining us online. So David, if I stop sharing the screen, are you able to share your screen?
I think so.
No, we can see that here and we can hear you as well, which is great. So I will mute our mic and then I'll pass over to you. Thank you.
Let me see if I can. Yes. Is my scrolling working?
Works for us. I'll pass over to you, David. Thank you.
Okay, thank you very much. Yes, I'm really quite disappointed not to be able to get there in person, but such is life. Hopefully I can catch up with a lot of the people who are there at some sort of similar event in the not too distant future. It's been a really good day. So yes, I want to talk about peer assessment via comparative judgment. Fortunately, I don't have to say too much about comparative judgment because of I think it was the first invited talk this morning. So my motivation here is to try to be able to ask more open-ended or conceptual mathematics questions. And I want to get students to think about their writing a little bit as well, which is both of these things are things that we don't very often get students to do in most, certainly in traditional maths modules and courses. One of the reasons for that is that maths assessment traditionally demands fairly rigid mark schemes, and these are really not very conducive to asking open-ended type questions. And so a solution that I saw when I was working down at Loughborough University was comparative judgment, and another advantage of this is that it offers some peer assessment opportunities as well. So I've used it in a first year multivariable calculus context, and most recently in the second year probability methods module that I've been teaching for the last 7 or 8 years now. So the types of questions that I can get students to answer are, here's a piecewise function, describe its properties in terms of limits and continuity, and 1 year we included differentiability in there as well. So there are these nicely continuous differentiable functions put together in different pieces. In some places they join together discontinuously, in some places continuously, and in some places in a way that's differentiable as well. And we gave students a single side of A4 just to answer that very generic question. Here's an example of what I've done in second year probability. The details are perhaps not quite so important, but this is a wordy question which requires students to interpret a short paragraph of English in terms of some probability distributions and random variables, and then do some calculations with those random variables in order to find a mean. But I want them to be able to do the modelling side of things a little bit as well. I'm not going to say much about the comparative judgment part here. We just compare we compare pairs of responses and say which one's better, as opposed to trying to look at the absolute quality. And we have a statistical model sitting behind it. So my explanation, I suppose, might be a little bit different. I would talk about a Bradley-Terry model rather than a sorting algorithm, but the output is essentially the same in the end. And so here's the online comparative judgment engine that I have used. It's a website called nomoremarking.com, which is aimed at school teachers, hence the name No More Marking. But here are 2 different responses to this question, one on the left-hand side, one on the right-hand side. Students have to click on left or right. They have a prompt, which response demonstrates the better mathematical understanding. And within this system, I get to impose a number of comparisons that is required, which in this case is 20, which is indicated at the top there, the number of comparisons that a student has left to do in their part of the peer assessment. The kind of output we get, so we can rank all the scores, so each submission gets a score here on a scale from about -4 to +4, and there's some standard errors involved as well because I'm statistically trained, and there's then an interesting question, lots of interesting questions. How do we turn that into marks? Those were briefly addressed beforehand. I've not got time to go through all the details now. There's some moderation involved, so we have can have a lecturer or postgraduate demonstrator doing lots of judgments to check that everything comes out all right. We have misfit statistics, which allow us to identify submissions which don't really fit, which we might need to give a little bit of manual attention to. Misfit statistics can also allow us to identify judges who are not behaving consistently with everyone else. So we can identify students that weren't taking the peer assessment very seriously as well. And then there's a whole lot of arbitrariness in how we decide, I beg your pardon, to assign marks. The rough timeline I have used is that I provide information and a practice run of this procedure very early on in a semester. A week beforehand, I distribute the question. I warn tutors and lecturers not to help too much, but I do encourage students to talk to each other. We then have them uploading their coursework through a VLE. I upload answers to the online comparative judgment tool, give a demonstration of how it works, and then within a couple of weeks I can give marks and traditional feedback on common errors and so on. One thing to point out briefly, I suppose, surveying students as to what they thought about it. So in my second year probability module of about 250 students, I got responses on a paper-based survey as to whether they thought this kind of thing was beneficial. So on the left-hand side, from the responses I've got, we can see that a very large majority agreed that looking at an extended response type question was a beneficial thing to do. However, on the right-hand side, we can see that their views on comparative judgment were perhaps a bit more mixed, but still overall fairly positive. suppose we also need to take into account the caveats of this being a self-selecting sample of people who have replied, and also the fact that we are asking students what they think about something as opposed to actually assessing whether it might have really been beneficial for them or not. So in conclusion, I think this kind of exercise is a big change from what happens in a lot of our modules at the first and second year level, in particular here at the University of Nottingham. This is one of the many changes that's been coming in recently, prompted to a large extent by COVID. But there's a lot of other things going on as well. We're developing both subject-specific and transferable skills. Students seem to generally think of it reasonably positively. They don't require very much training. And I was hoping, if I was there, to be able to start a bit of a conversation about the pros and cons of this kind of approach. Doing the paired comparisons, students do get to see a lot more different responses to the questions because they're not required to dive in quite so much detail to each submission that they might be required to do if they were doing more traditional types of peer assessment. And so what are the pros and cons? I'd be very interested if anyone would like to get in touch with me and share some thoughts or ask some questions now. And if anyone's interested, there's a lot more detail about what I actually did in the first of those papers that's mentioned at the bottom of that slide. So thank you very much for your attention, and hopefully that all worked.
Yeah, that worked. Thank you. Any questions for Dave?
On the Zoom chat.
Do you want to read that out for us, Craig?
Yeah, sure. So Sam's just asking, Dave, have you or someone in the lecture you know of looked at comparing the final ranking score that items get to the judgments made by individual students to look for instances of students appearing to make judgments purely at random?
Yeah, is the short answer. I include in my marking rubric some marks for participation in the peer assessment. And what's the criterion I use? I require at least half of their judgments to be consistent with the overall final rank ordering. So students, unfortunately, students of probability ought to be able to work out the chance of getting that correct, getting those marks, even if they just guess. But yeah, it's very easy to look at for example, the proportion of times that students click on left or right. You can also see the amount of time it took them to make each judgment. And so I deliberately set a fairly low bar for that engagement, just to make sure that they're not just taking 2 seconds for each judgment and clicking left every time.
Perfect, thanks, Dave. There's one other question just on Slido. It's just regarding what level of manual intervention is required, i.e. what proportion of misfits are there?
So that I discovered, much to my disappointment 2 years ago, I think it was, that if you don't set your question a bit carefully, then things can go wrong in that way. So I ended up with a question where students could make a fairly fundamental mistake in their calculations, but the numbers dropped out that they still got the correct final numerical answer. And so the peer assessment went horribly wrong then. But accepting cases like that, yeah, my informal experience is that it seems to go all right. I'm not sure if I've ended up diverting a little bit from the question there, but on my screen at the moment, I can't find the Slido to remind me of what the question was, sorry.
I think that was relatively well answered in my opinion. So one last question just appeared in Zoom, then we'll break out for lunch, just for Ben. So what do you make of using judge infit/misfit for checking the validity of peer assessments?
The use I make of it is I just look to see, so a judge misfit. Okay, I was about to start answering that question about script misfit. So for judge misfit, yeah, I just look to see the top half a dozen, the most misfitting judges, for want of a better phrase. And then I look in a little bit more detail at actually what their judgments were, whether they seem to take it seriously based on the number of left and right clicks.
Thank you very much, Dave. I think we'll break there for lunch. I'd just like to say, for any questions on Slido we didn't get to, we will ask our speakers to have a look at those and respond. I guess the only thing left to do is thank all of our speakers again.